What's up, everybody? I'm Matt Gary, and in this episode of Coding with the Force, we're going to go over the Interface Segregation Principle. What it is, why it's important, and how to actually implement it in both Apex and JavaScript. Alright guys, so today in this fifth episode of the Solid Design Principles tutorial series that I'm putting together, we're going to go over the Interface Segregation Principle, what it is, why it's important, and how to actually implement it in both Apex and JavaScript. So we'll start off with what the Interface Segregation Principle is. The Interface Segregation Principle, I think, is a lot more than its definition maybe leads you to believe. If you go out and you Google what the Interface Segregation Principle is, and you look on Wikipedia or even most other tutorials, basically all they're going to tell you is that the goal of the Interface Segregation Principle is to break down your interfaces so that classes that implement your interfaces don't need to depend on or use methods that are irrelevant to them, more or less. So first things first, if you have no idea what an interface is, please go check out the interface tutorial that I've created. Otherwise, you might get a little lost in this episode. You'll probably get really lost. So I'll link it up above and in the description. Go check it out. Don't waste your time watching this unless you know what interfaces are and how to use them. That said, so when you go look at definitions of this out there, they're all going to tell you pretty similar stuff. Interface segregation principle, you have a big interface that the vast majority of methods are useful in most of the places that implement it, but there's still some methods that classes are forced to implement that are completely useless to them. And so now you have classes depending on methods that they don't need and there's no reason for them to use, right? So the goal is then to break down your interfaces into smaller sub interfaces, or I think some people call them like role-based interfaces or something along those lines. And that way your classes only depend on the interfaces that they should care about. Or they only implement methods from the interface that they implement that they should, right? Anyway, I think what the goal of the interface segregation principle is a little bigger than that, though. Really what the interface segregation principle is trying to achieve is not allowing your code to have dependencies on things that it shouldn't need to depend on in the first place. And you might think like, well, what does that mean? Well, I think we've all at least once been in a situation where somebody has built a gigantic class, right? And that class has 60 methods in it. We'll just we'll be a little easier. It's got 20 methods in it, right? So we've got this gigantic class. It has 20 methods in it, and like 4 or 5 other classes in your system call this other class, right? And class A only uses method 1 and 2 in this gigantic class, and class B only uses method 3 and 5 in the gigantic class, and so on. So even though class A only calls 1 or 2 methods in this gigantic class that lots of classes depend on, it's now dependent on a bunch of other methods that it doesn't need to be dependent on. And you might think like, well, why does that matter? I mean, who really cares, right? But it matters. And it matters because you don't know what other people are going to do in your system. Maybe you're the only developer, and that's wonderful. But someday that might not be true. and somebody changes the method declaration that one of these, in the gigantic class, say it calls another class that has a, calls a method in that other class, and you've changed the method declaration that class calls. Well, now that whole class is going to fail to compile, right? And now tons of other classes that don't even care about this method in the gigantic class, they don't use it, they don't care about it, are going to fail. And let me just quickly show you what I mean by that, because that's a tricky thing, right? We've got this class called class everything depends on, and we got method A, method B, method C, and we've got nope, not that one, class that depends on method A. So there's this gigantic class everything depends on, and it calls method A, so it calls this one right here. And there's class that depends on B, and it calls method B down here. And then last but not least, there's class that depends on C, and it just calls in this gigantic mega class that I've created here. Really, it's a small class, but I'm trying to illustrate a point. And it just calls method C. So class that depends on A, it only calls A. Class that depends on B, it only really cares about method B. And class that depends on C, it only really cares about method C in this gigantic class here, or this class with a bunch of methods. Now what would happen, right? I've got in method A, it's initializing another class or instantiating another class and calling this cool function method. Well, right now everything's great, right? Now if I bring up my anonymous apex here, and I said, call class that depends on B and run this, everything's fine. It works. We get that debug call. Method B was called right here, and that's great. But what happens if I go into this class that method A calls, and I decide, because I'm a developer that's working on something totally different and I need this function to do something totally different right now, to just add a parameter and say string taco or something, right? And I save this. Well, here's the thing, that's going to save, but this class is going to fail to compile now, and nobody knows it yet, right? So if I hit play on this, now you see, even though class B, this guy, doesn't care at all about method A in here, it doesn't matter. It still failed to compile. It's broken, and that sucks. And you maybe have 20 different applications running from this one giant class, in a bad situation anyway. And now they've all broken, and for no reason, because none of them care about method A except for maybe one, right? So the goal of the interface segregation principle is to remove this problem, right? If you look at it in a broader sense, especially if you read about it in Robert C. Martin's books, which are really the best place to read about these, since he's kind of the guy that kind of coined them and all, shoved them all together. Now, he didn't come up with these principles, but he's the one that plucked them from the many, many principles in software development or software engineering and coined the solid principles or put them together. Technically, he didn't even come up with the phrase solid. Somebody else rearranged his principles and told him he should do it that way, but whatever. We're getting off track. The point of this is don't make your code depend on things it shouldn't depend on, right? Now, and in my opinion, and what you should strive for is to make that happen everywhere, not just with interfaces, right? So I'm going to show you how to break this up using interfaces. And then I'm also just going to, show you how you break this up if it was just a normal class that didn't implement an interface, right? So, yeah. So I think we've figured out what the interface segregation principle hopes to achieve, why it's useful, because if I hadn't, made this big class that all of my other classes depend on, despite not needing most of the methods in it, well then I wouldn't have this failure I've got myself into, right? So, yeah. Let's figure out how to actually fix this situation. The first thing that we'll take a look at is how you might break out your interface, right? I'm not going to spend too much time on this, to be totally honest, because I kind of think this is pretty intuitive, unless you've got yourself into a really complicated interface situation, which I'll be honest, doesn't seem to occur too often in Salesforce unless you're working with managed packages or something. So let's just check it out though. So we've got this class everything depends on, and it implements this tons of methods interface. And if we take a look at the tons of methods interface, it's just got method A, B, C. And as we know, all of our classes that we currently have anyway, class that depends on A, class that depends on B, class that depends on C, all of these classes, they only care about, one of those methods. They don't care about every single one of the methods in here. So really what we'd want to do is create interfaces that were more appropriate, right? And service classes that are more appropriate. So this class everything depends on would likely be like a service class, because this is something that everything else is calling. Now Salesforce is going to hate me, or IntelliJ is going to hate me for doing that. But basically what we'd end up doing is we know that class that depends on A only calls method A in this gigantic class. So what we'd do is we'd break it out. We'd have, we'll just say a method A interface, and we'll say, class A service or something. And we'll have this implement the class, First thing I gotta do is actually make this an interface. Interface. And we'll give this void method A. We'll have this implement the method A interface. Oop. Right, so now this service is broken out a little bit, and we can just grab this code that we originally had in method A over here and get rid of this method entirely, which this is going to hate, but that's okay. That we don't, actually we'll just leave it for now, but we're going to basically scrap this whole method eventually. So we've got this method A interface, and class A service implements method A interface, and now we've got this added in here. I'm going to just open this up really quick so that I can fix this so it'll compile again. Otherwise, we're going to have problems when I save this in a second. And we are going to have class that depends on A. Now instead call class A service. And just have it call method A, right? The only method that it cares about. And we're going to, actually, so we can illustrate a point here, I suppose, I'm going to go to tons of methods, remove method A from here since we've already broken it out, right? And we will come back in here and get rid of method A. And now, if we save all that, we've removed or we've siloed, you know, class that depends on A, so that it only cares about a service that has just that one method that it cares about. And of course, this is a very simple example, and I'm realizing maybe I should have made a little more complex, but you know, this could have tons of other methods in it too, like private methods that it depends on in here, and it could go on and on. So it's in all likelihood, whatever you're dealing with isn't just going to be one method. It's probably going to be like 4 or 5 or 12 or 15. So even though this is very simple, just so I can quickly illustrate an idea here, it won't be in practice for sure, unless you got an extremely simple work. So, all right, so we've broken that method A out. Class everything depends on is now not, now class A does not actually depend on it, right? So that's great. That's great for everybody. And I say that because I'm going to go break that other method again. I'm going to go put a string taco in here and save this. So if you remember, that's what this calls. That calls that cool class, cool function right here. And now this isn't going to compile. But you know what? If we run that anonymous Apex code again, where we just have class B call the method in the class that everything depends on, well, guess what? It's still going to run, which is magical, right? Now, even though if I change this up and had this call class A, it would fail miserably. Class B is still good to go, right? So this one, it's not going to compile, but class B, still good to go. Class C, still good to go. And basically what we would do is we would replicate this for all the other classes and all the other situations, right? So we'd break out class everything depends on and its interface tons of methods. We'd make another class for method B. We'd make another class for method C. And we'd make an interface for each of those classes, right? Just like we just did for A. And we'd fix our problem, because then our classes that only depended on those methods would only call those methods that it depended on and nothing else, which is in reality the whole point, which I know I've stated already, but ultimately you just don't want anything to depend on stuff it doesn't need to depend on, because that puts your code at risk for failure in ways you can't anticipate right now. Well, you probably can, but you don't know what's going to happen in the future. If you've got a big mega class and lots of things are calling it, but lots of things are only using a small portion of it, you need to break it out into small pieces. And you need to make sure that those pieces can be compiled together in the classes that actually care about it. And you know, if I did go back into the class that everything depends on, and I went forward with everything, and I say, you know, I made a class B service, and I made a method B interface, just like last time, and we made this an interface. I said void method B. Cool, so now we've got these things broken out, and if I go back to class everything depends on, I can grab this guy, put it into the service class just like last time, have it implement method B interface, and remove method B from tons of methods, and delete this. And last but not least, we would also want to call, in this one, class B service, and we're good to go, right? So now class that depends on B only depends on code that it really cares about, right? Now you might be thinking to yourself, well, what if I've got a class that depends on both A and B? How do I satisfy that situation? Like, I've got one that cares about method A and method B. Well, what do I do? Like, how do I handle that scenario without replicating my code a whole bunch of times and whatnot, right? All right, so let's figure out how to deal with this situation, because it is a real situation, right? You know, what if I have another class that needs to use the class B service or the class A service, right? Sorry, and the class A service. I need one that uses both class A and class B and adheres to both of their interfaces. What do I do, right? Well, if I've got a situation like that where I actually need both of these services and I depend on both of these services, and say, you know, and that was a real situation, basically what I'd do is I'd create another class. We'll call it class D or class E service, and I'll zoom in here, and we'll have it implement method A interface and method B interface, and we'll add both of those methods. So we'll say, ooh, I'm getting far away from the mic here. We'll say public void method A and public void method B. Oh, or that's not what I'll type. All right, so we've got that, and we want to use both the services. Well, that's pretty simple, right? Class A service, class A equals new class A service, class A dot method A. And then we do the same thing down here, but for class B, right? So we just do class B, blah, 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 blah. And then we'd have, you know, another class, class that, what did I call these? Class that depends on A and B. And then we'd have it call method A and method B in that class. So we've got the public, you know, we don't need to do all that. But basically, we'd write a method that calls method A and class E service, and then another one that calls method B and class E service. All right, perfect. Or you might not even need to go that far. You could really just potentially break it out and just have a method in here that calls the class A service and another method that calls the class B service. You could do a bunch of different things, but at this point now, you know, your dependencies are broken out. This cares about its dependency, whether it calls this combined service class, if that was actually necessary, or it calls the individual class B and class A services. Either way, you are in this class only using what you're depending on, and in all your other classes now you're only using what you depend on. Now I will say, I'm just going to show you guys something that I don't know that you should particularly use, but once you've broken your services out of your giant monolithic class that we had in the beginning, right? We had that big class everything depends on. this guy, which is now just a couple methods, but it used to look like this, right? And everything called this class. Now that we have our class broken out into, or our classes broken out into different services, there's kind of an interesting thing that you can do, right? If for some reason you're one of those people that are really afraid of classes in it growing and growing or something, which I don't think you should be, there's a pretty interesting thing you can do. So I'm just going to show it to you. But I don't know that I would necessarily recommend it, but it is a cool thing that I found out, so I figured I'd let you know. Right now, just before I do this, if I actually called class E service and I called class B, it would fail because this thing still won't compile. Right? So if I called class E service, which I think I've saved, oh boy. Class E service is invalid because it calls this method, which doesn't work. So let me go fix this guy real quick. And let me save that. And then I'm going to unfix this and come back to good old class E here that has both of these guys. So if I opened up my anonymous Apex right now and I did class E service, class E equals new class E service, and then I said class E dot method B, well, it'd break, right? And that's okay because the things that are calling class E service depend on both of these methods, right? Theoretically. So really there's nothing wrong with this. But you could actually fix this problem in an interesting way. So if you wanted it to be even more contained, right, and a call to method B only cared that method B was working and not whether or not method A was working, which again I don't know that I'd suggest, but I'm just going to show you this because it's kind of cool and interesting in my opinion. You can do this type initialization like this, right? And now at this point you've got a real separation between your classes. Class E service literally at this point knows nothing about class A. It knows nothing until it starts to run. So basically I'm initializing a type and I'm passing it the name of the class that I want to initialize the type for, and then I'm going to create a new instance of that class at runtime via its interface, and then I'm going to call method A. Okay, well if I save this, because there's no real connection between class E service and class A service anymore, if I run that method B that just failed, that we just did, it's going to compile, which is pretty cool, right? And through this little technique here, you can get what is in reality like the most perfect form of separation, right? Like this class now knows nothing about class A. It depends on it. It doesn't depend on it at all. It depends on the interface, right, to compile. It depends on the interface, but it doesn't depend on class A. So if you go out and you like, you know, break everything in class A or just straight up delete class A, technically class E will still compile and it'll be fine. And so you've got real significant, you know, loss of dependency between those classes, which is something that's super important, especially when you talk about like dependency, inversion principle, and stuff like that. But we'll go over that next week. But anyway, just so you know, you could implement this practice here, and then you get like this ultra, you know, form of not having anything depend on anything that it truly doesn't need, right? So like if I'm calling method B at a certain point in time, and I'm only calling method B for some reason, like say when you called this service class, the other class truly did need everything in service class E. So if I was in here, it truly does need both of those things. But in certain situations, it's only going to call method A or it's only going to call method B. You know, that's an interesting way to kind of break it up. But again, I don't know that I would suggest this, but it is a cool thing. And in certain situations, it is very useful to leverage. But anyway, I'm just here to show you the cool thing. You have to be very careful with this because you have true dependency separation, and sometimes that can actually be pretty bad. So be careful with it. But just know it's a tool you could use in the right context. All right. So I think we figured out in Apex how we can kind of, break everything out. You take a big, gigantic class that everything depends on, despite the fact that most of it doesn't actually depend on it, or most of the other classes that call it don't depend on the vast majority of it. And you put those things into their individual services and their individual interfaces. Now, they could be much more complicated, like we already talked about, than this example. When you break out Class A service, it really could, and in all likelihood, will be like 10 different methods, right? It's not just going to be method A. It might be 10 different methods that compose Class A service in a real-world situation. But you've broken it up so that, you only have things be dependent on, you only have things calling Class A service that are truly dependent on everything in Class A service. And that's really the whole goal of the dependency inversion principle, in my opinion. So we can really quick just see how to do this in JavaScript, although I think you probably get the point. But JavaScript is obviously a little different because there's no such thing as interfaces, right? Which we've covered several times already in this tutorial series. But let's just give it one more go, shall we? All right, so in front of me, I've got this utilities service Lightning Web Component, and it's got a create toast method, a create error log method, create console log, and pop modal. And I guess this is a Lightning Web Component, but really it's just a JavaScript module that has all these methods in it that I could use in another Lightning Web Component. So that said, these aren't exactly 100% focused. You could probably imagine there'd be some Lightning Web Components that would only want to create toast, some that would only want to create error logs and console logs, and some that would only want to pop a modal, right? So how would I deal with this situation, right? Like, how do I make it so that we're not dependent on everything in a class, in a Lightning Web Component? So right now, right, if I create a new Lightning Web Component, and we'll call it cool component or something. Yep. And we imported this, so we'll import utility service. That is not gonna like that. Would probably want it that way. Then, we're importing that whole class into our Lightning Web Component, right? And so now we depend on this entire utility service class, which maybe isn't great, right? Because something could go wrong in a method that we don't care about, and that would be less than ideal, right? So how do we fix this? You can fix it in a bunch of different ways. Actually, a couple different ways. Number one, you could break this out into different classes, so it's not just one generic utility service, right? You could make it so that it's a toast service that just creates different types of toasts. You could do one that's like a logging utility, a logging class that you could then import when you wanted to. And you could do one that's just like a modal service that does modal related methods when you want to. Or you could just export these individual methods, right? So we'll see both of these both of these ways, both of these situations. But let's just take a look at them, right? So if I wanted to break these out into each individual function, I could just do the following. I could say export function create toasts, just like this, but not not like that. And then what I could then do is, if I went back over here to my cool component and I went to the actual JavaScript file, then I could just say, import create toast from utility service, and I could just use that create toast method, right? Just like that, which is pretty cool. And I could do the same thing for each one of these methods, and that way I could just import each method as I needed it, right? And then you only are dependent on the methods that you truly care about. But you could also go the other route if you wanted to stick with an exported class, because sometimes that's a little easier to deal with and it's easier to group things. So you can actually have multiple exported classes in one JavaScript module, and you could say export, we'll say toast class, not that, and we'll do create toast in here again, and there you go. And then you could just say again in your component, I want to import the toast class, right? And that way you got this kind of granular breakdown, much like we just did in Apex in a different way. But now in JavaScript, when I'm importing stuff into my Lightning Web Components that I want to use, I have a much more granular choices, right? I don't have to pick this whole utilities service class and import the whole thing. I could just, make the ability to export the individual functions so that I could import it function by function as I needed it in my different Lightning Web Components, which would then make it so that I have no dependencies that I don't actually care about, which is great. Or if I really wanted to group them by classes, I could just break them out into their appropriate classes, much like we did in Apex, right? So again, no interfaces in JavaScript, but again, just to reiterate this one more time, the interface segregation principle is all about getting rid of dependencies that you do not care about and should not be, in your code, right? If I was still in this component and I was importing that whole utility service here, but I had a connected callback and it just did, like an initialization of this. Well, now I depend on literally every single method, but I maybe only care about creating toasts, right? Maybe I only ever call create toasts. Cool, but I've now imported this whole thing, so my whole component depends on the whole thing, which means a bunch of things, right? Like my component will load just a little bit slower because I have to load in that whole thing. It also means that, potentially this could have a compilation failure because of something else within this class that I don't ever actually use, like we talked about in Apex. And yeah, so try to make sure you only make your code depend on what you need it to depend on. If you've taken away nothing else from this whole conversation, it's just that the interface segregation principle's main purpose is to make sure that your code is as insulated as it can be, right? It does not depend on junk that it shouldn't, and it never will depend on, right? And that way it only breaks when something that it really cares about and needs for its own operation breaks, right? This is a great principle. You should strive to do to implement this everywhere, because you'll find that your code base is a lot easier to deal with. You have a lot less things breaking everywhere all of a sudden for weird reasons you can't really explain. And it just makes it simpler overall too, in my opinion, to look through and figure out, when you break your classes out like this. But anyway, I think that ought to do it for today, guys. I hope that this has been helpful. And if you like the video, make sure to actually click the like button below. Subscribe so that you can see the next video. And hit the bell so that you know when the next video actually, happens. But anyway, guys, I hope you've enjoyed the video. And I look forward to seeing you next time.